We are on page 215 of lesson 4.3, multiplying and dividing rational expressions. We'll go ahead and do 17 through 30, maybe 31. We'll see how that looks when we get down to the end, but we'll probably go ahead and talk about it anyways. If you watched the last video, the part 2 video, you'll notice that in one of the examples, we were dealing with a cubic. You couldn't factor using the grouping method or something like that. So we talked about the rational root theorem and how to find something that divided that cubic. I'm not seeing that here. So if you would like kind of some more explanation with that, if you watch that example, just since we're here, let's go ahead and find it. It was example 5. Over here on example 5, page 212, we talked about dividing this cubic, breaking it up so we could factor it. And we talked about coming up with those list of possible roots. So if you don't remember that, just go back to part 2 and watch that, and you'll see how that's done. It's a pretty straightforward method. It just can kind of take a little bit of time to go ahead and do. So, but I'm not seeing any of those in the practice problems. So I'm not exactly sure why they put those in the example problems and then none of the practice problems, but it is what it is. So, all right. So write an equivalent expression, state the domain. You're essentially doing the exact same thing you're doing here. What is the simplified form of each rational expression? Just kind of a different way to ask that question. What you're essentially doing is just simplifying that fraction. So just like we talked about in part 1, when you simplify a fraction like, 3/18, you're basically finding a factor of 3 and factors of 18, and you're just dividing those out to make that fraction smaller. If you can. You can't always, but sometimes you can. In these examples, since we're dealing with Algebra 2 level simplifying, now you are factoring, and then the way you simplify it is you'll cross out a common factor on the top and the bottom. So like I said, if you don't know what I'm talking about and you haven't watched parts 1 and 2, just go back and watch those and that'll make more sense. So for number 17, what we're going to do is factor. So when you factor a cubic, a quadratic, whatever you're looking at factoring, the first step is to always take the GCF. So if you didn't know that and you're writing down notes, maybe write yourself down some steps. Step 1, take out the greatest common factor. And if you don't remember what that was from, I don't know, I think it was back in chapter 2 or something like that when we talked about factoring, just either go on YouTube and watch an explanation of what GCF is, greatest common factoring, or just contact me and I'll explain it to you. So for number 17, with that numerator, I noticed that all 3 of those terms have at least one x in them. So what I can do is I can divide out, I can take out of all 3 of those terms an x. So when I do that, x cubed divided by x, that's essentially what I'm doing, is dividing. So x cubed divided by x is x squared. Another way to think about it is 4x squared. If I take an x away from it, I had 2. Now I'll just have 1. And then negative 12x, if I take that x out, I'll just have negative 12. If I could take out a GCF that was a number, like if this leading coefficient was like a 4 or a 2, I would have done that as well. So you always want to take out the greatest common factor if you have a number or a variable. That denominator, you'll notice, is already a quadratic. There is no GCF here. There's no number or there's no x's in all 3 of those terms. So I'm just going to leave that as a quadratic. So x squared plus x minus 30. And now that I have quadratics in the top and the bottom, now I'm going to factor. Kind of like we talked about back in chapter 2, whenever we learned about factoring, lots of different ways to factor. You can use guess and check. You can use the box method where you're GCFing out from the box. I'm going to use this cross method that we've talked about before. And again, if you need an explanation on a different method or you want to see a different method, just contact me or stay after class, and I'd be happy to explain a different one to you. So the way this works, AC goes at the top. So A times C, and then B goes at the bottom. So in this case, A is 1. It's the number in front of x squared. So that's 1 B is 4, it's the number in front of x, and then C is the constant in the back. So 1 times negative 12 is negative 12, and B is 4. I need two numbers that multiply to negative 12, and those same two numbers have to add to 4. So I think 6 and negative 2 are it. Double check, 6 times negative 2 is negative 12. 6 minus 2 is 4, so I think that works. Don't forget factoring. This can be a little bit difficult, especially if your multiplication facts are weak. If you have a number like, I don't know, 48 up top, that can be a little more difficult to pick those two numbers. The smaller numbers are a little bit easier. So if you need to, go ahead and write those factors out underneath it until you find a set of factors that actually work. So this is a positive 6. So in my numerator, I already have that x out in front. I've got a positive 6, so it's x plus 6. I got a negative 2, so it's x minus 2. And then I'm going to do the same thing with my denominator. Go ahead and factor that. So AC at the top, 1 times negative 30. And then B at the bottom, that's a 1. Two numbers that multiply to negative 30 and add to 1 are 6 and negative 5. So my denominator, once I factor that quadratic, it's going to be a positive 6. So x plus 6. It's going to be a negative 5. So x minus 5. And here's that part I was talking about before. Now you're looking for common factors that are in the top and in the bottom. Like I talked about in part 2, don't start thinking, well, here's an x inside that parentheses, here's an x inside that parentheses. I can just cancel those out. That's not a factor. This is an x times something. This x is being added or subtracted to something, right? It's x minus 2. It's x minus 5. So you can't cancel out across addition or subtraction, but what you can do is you can cancel out these factors, all these things that are being multiplied. You can cancel any of those out. And then this x all the way out in front. So I've got 5 factors. These are all being multiplied. X times that, right? X plus 6 times that. So you have to cancel out the entire factor. In this case, I have an x plus 6 up top and x plus 6 down below. I've got an x up top, but I don't have any factors of x down below, right? This is x is being added to negative 5. This is not being multiplied. Same thing with x minus 2. I don't have an x minus 2 down below, or I don't have an x minus 5 up above. So I think my final answer is going to be that x up top times x minus 2. My denominator is x minus 5. And then like we stressed out in the beginning, part 1 and part 2 of this lesson, there's a big no-no you have to watch with these example problems. If you go to your calculator and you type in whatever, 13 divided by 0, negative 7 divided by 0, 0.5 divided by 0, it doesn't matter what it is. If you divide something by 0, it gives you an error. You can't do it. It's like kind of like illegal in math land. You can't do it. So what I need to do is I need to go to this step right here, the step before I've canceled anything out. So kind of imagine that that's not crossed out yet. I need to look at everything in my denominator and I need to exclude, that's why it says x is not equal to, I need to exclude any number that's going to make my denominator 0. So kind of like we talked about in the example problems, what you can do is you can take each factor and set it equal to 0, the other factor, set it equal to 0, and you can solve it. So here I'd subtract 6 from both sides, so I get x equals negative 6. Here I'd add 5 to both sides, so I got x equals 5. So those are the two numbers that are going to make my denominator 0. So I have to exclude them. That's my final answer. Keep in mind, if you plug these in, you can check that. Negative 6 plus 6 is 0. 0 times anything is 0. If I plug in 5, 5 minus 5 is 0. 0 times anything is 0. So those two numbers x cannot equal. Number 18, more of the same. So we'll go a little bit quicker this time. So my numerator looks like it has a GCF, not only an x in both of those terms, but it looks like I can divide both of those terms by 3. So I'm going to take out a GCF of 3x. Again, when I say GCF, if you're not sure what I'm talking about, pause the video, go to YouTube, Google what is a GCF, and watch a 5-minute video. It'll help you out. You got to be looking out for that, or just contact me and I'll explain it to you. But like I said, you're just looking for a number and a variable that you could pull out of every single term, right? I can divide this term by 3. I can divide this term by 3. So I took a 3 out. I can divide this term by x, and I can divide this term by x. So I took an x out. So what's left over? 3 divided by 3 is 1. X squared, if I had 2 x's and I took 1 out, I'll have 1 left over. 15 divided by 3 is 5. I had 1x and I took 1 out, so I don't have any left over. Then my denominator, x squared plus 3x minus 10. Set yourself up with that cross method. A times c at the top, b down below. Two numbers that multiply to -10 and add to 3 are 5 and -2. So my denominator, I took that quadratic and I factored it. It's going to be x plus 5. And then it's going to be x minus 2. Now I look for common factors. I've got an x plus 5 up top and x plus 5 down below. I've got a 3 up top because this is 3 times x, but I don't have any 3 or any multiple of 3 down below. I've got an x up top and no x's down below. And then I got an x minus 2 down below and no x minus 2 up top. So I think I'm left over. The rest of that is my answer, 3x over x minus 2. And remember, you always got to put those domain restrictions. You always got to state what x cannot equal because your denominator will equal 0. And remember, the step we're looking at that after we factor it, after we do the cross method, after we take the GCF, once we factor everything apart, that's the step I'm looking at. So what's going to make each one of these factors equal 0? Again, ignore that I crossed that out. I still have to exclude that number. So you can do what I did in the last problem, put x plus 5 equals 0, put x minus 2 equals 0 and solve it, or just look at it. What plus 5 equals 0? -5, right? -5 plus 5 is 0. So x can't equal -5. What minus 2 is 0? +2. 2 minus 2 is 0. So x can't equal +2. Another way people think about this is you're just taking the opposite of that constant. So the opposite of +5 is -5. The opposite of -2 is +2. So we'll go to 19. Again, more of the same. Ignore that this is y's now. It's treated the same thing as x's. They're just using a different variable. It's totally fine. So for our numerator, there's no GCF here. There's no greatest common factor that I can take out that's a number or a variable. So I'm just ready to write these in my cross. A is 1, B is -5, C is -24. So 1 times -24 is -24. B is -5. Two numbers that multiply to -24 and add to -5. It's going to be -8 and 3. Remember what I said, always double check yourself. Once you choose those numbers, make sure they work. -8 times 3 is -24. -8 plus 3 is -5, so that works. So for my numerator, it's a -8, so it's going to be y minus 8. It's a +3, so it's going to be y plus 3. And then my denominator, y squared plus 3y. Both of these terms have a y in them, so I can GCF out a y. And then the denominator, if I take a y from y squared, I'll be left over with 1y. So there'll be a y right there. If I take a y from 3y, I'll be left with just the 3. All right. So Remember, the only thing I can cancel are factors, things that are being multiplied. So I can't cancel this y and this y, or this y and this y, because those y's are being added and subtracted, right? So I have to cancel the entire factor, the entire thing that's being multiplied. This is where people screw up a lot, so make sure you're paying attention to that. I can only cancel the thing that's being multiplied, the entire set of parentheses. So I got a y plus 3 up above, a y plus 3 down below. I think that's it. So my numerator is going to be y minus 8. My denominator is going to be y. And then remember, I have to state that y cannot equal anything that's going to make that denominator 0. So just like I said before, you can take each of these factors and literally just set them equal to 0 and solve them. So with y equals 0, that's it. You don't have to solve it. There's nothing to add or subtract or manipulate. With y plus 3, I have to subtract 3 from both sides. And I get y equals -3. So in this case, y cannot be 0 or -3. 20. So this one's a little bit more involved, right? A little more stuff, but again, trust the steps, just do one step at a time. So for number 20, take a look at your numerator. Looks like both of those terms have one a in them, right? There's an a there and there's an a there. So I can GCF out an a. This term has a b cubed. This term has a b. So both terms have at least one b in them, right? Even though this has b cubed, this one only has one b that I can take out of it. So the most amount of b's I can GCF out is just one of them. So for my first term, if I take that a out, I'm not going to have any leftover a's in the inside. If I had a b cubed and I took a b out, I'll be left with b squared. I've got a -9 still. I didn't take out any constants, any numbers, so it's still going to be -9 in there. I took an a out and I took a b out. So the only thing left from that term is just that -9. The denominator. All three of these terms have a factor of 12, right? That can be divided by 12, that can be divided by 12, that can be divided by 12. So I can GCF out a 12. All three terms have one a in them, so I can also take out an a. That's got a b squared, that's got a b, but there's no b's there, so I can't take any b's out. So when I go through each of these terms, I'm essentially dividing each term by 12a. So 12 divided by 12 is 1. I took that a out. All I have left is that b squared. 12 divided by 12 is 1. I took that a out. All I have left is that b that's right there. -144 divided by 12 is -12. I took that a out, so the only thing left is that -12. So by simplifying that problem, by taking out an ab up top and a factor of 12a down below, now I've got a couple of quadratics. Think about that just like x squared minus 9. This is x squared plus x minus 12. So just factor it just like normal. So my numerator, a couple different ways, and I'm going to show you both ways just to remind people how to solve these types of problems. I've got a b squared. I don't have a b. And then I've got a -9. So those two things are exactly the same. So if you want to, draw an x, a times c, my b value, two numbers that multiply to -9 but add to 0. So for my numerator, I'll have ab, and then it's going to be, since that's a +3, it's going to be b plus 3. That's a -3, so it's going to be b minus 3. The other way you can look at a problem like this, when it's set up like this, where you're missing your middle term, you're missing your b term, is you can do it just like this. B squared minus 9 equals 0. I can add 9 to both sides, so I get b squared equals 9. And then I can square root both sides. So the square root of b squared is just b. The square root of 9, don't forget when you square root a number, you got to include the positive and the negative. So the square root of 9 is positive and negative 3, which is exactly what we got up here. So whichever way makes sense, you can use either way. Don't forget in math, there's lots of different ways to do things. So if I show you a method on how to do something, more than likely I can show you a different method on how to do it as well. So just let me know. Then my denominator. I still have that 12a out in front. I'm going to go ahead and use the cross method, b squared plus b minus 12. So if I set this up with my cross method, a times c is negative 12. My b value is 1. Two numbers that multiply to negative 12, and the same two numbers have to add to 1. So that's 4 and negative 3. Don't forget, take a second to double check those. Make sure they multiply to negative 12. Make sure they add to 1. It's really easy to get those signs mixed up, and then you're off. So that's a positive 4, so it's going to be b plus 4. That's a negative 3, so b minus 3. And now I'm set up. I've got all these factors. Here's a factor, there's a factor, there's one, and there's one. The 12 is a factor, the a is a factor, the b plus 4, and the b minus 3. So what I'm looking for are common factors that are in the top and the bottom. So b minus 3 is in the top and the bottom. There's a b plus 3 up top, but not down below. There's a b plus 4 down below, but not up top. There's a b up top, but not down below. There's an a up top and down below. And then there is a 12 down below, but no number up top that I can reduce that down with. So what I have left up in my numerator is b times b plus 3. My denominator is going to be 12 times b plus 4. Just remember that restriction, right? They call this a domain restriction. What's going to make your denominator not equal 0, right? That's what you have to exclude. And don't think it's just this step. Don't think you did a bunch of algebra and you're just looking at this last step. That's going to be part of it. It's going to be negative 4, right? Negative 4 plus 4 is 0. So that's part of your domain restriction. But you need to look back at this step. The step after you factored everything before you canceled anything out. You're looking at this step right here. So look at each factor. I already said I had 4 of them. Well, 12 is equal to 12, right? That's not just going to randomly change to 0. But what about a, right? If a equals 0, that's one of the restrictions. There's that positive 4 that we still have down below. So negative 4 plus 4 is 0. So I want to exclude negative 4. And then b minus 3. 3 minus 3 is 0. So I want to exclude 3. 21. So more of the same. I'm going to kind of go a little bit quicker here just because we've gone through the processes and you can always rewind it and go back through. But what I want to do is factor that numerator. So x squared plus 8x plus 15. Draw my x. A times c is 15. B is 8. Two numbers that multiply to 15 and add to 8 are 5 and 3. So my numerator is going to be x plus 5 and x plus 3. Then for my denominator, same idea. Draw my x. A is 1, b is negative 1, c is negative 12. So a times c is negative 12, b is negative 1. Two numbers that multiply to negative 12 but add to negative 1 are negative 4 and 3. So in my denominator, it's going to be x minus 4 and x plus 3. So canceling out common factors, I've got a factor of x plus 3 up top and down below. Nothing else can cancel out. So my final answer is going to be x plus 5 over x minus 4. And then my domain restriction, don't forget you're looking at this step after I factored everything and before I canceled it out. right? So don't think just because this is canceled out, I don't have to take care of it. I have to look at both. So this is going to be that's a -4, so it's going to be +4. That's a +3, so it's going to be -3. 4 minus 4 is 0. -3 plus 3 is 0. 22, it looks like I can GCF the top and the bottom, right? The top 3 terms have an x in them. The bottom 3 terms have an x in them. So I'm going to be able to GCF out an x up top. And an x down below. All right. So I took an x from all 3 terms. I'm left with x squared plus 9x minus 10. I took an x from all 3 terms, and I'm left with x squared minus 9x minus 10. They look really similar. You might want to think, you might think everything can simplify out. Remember, you're only able to cancel out factors. So right now, you could cancel the x's out in front, but I cannot do this. I can't cancel out x squared and x squared. Why? Because these terms are being added to other terms, right? You can only cancel out a factor, something that's being multiplied. So if I wanted to, I could cancel out the entire set of parentheses, but these two things are not exactly the same, right? That's a positive 9x, that's a negative 9x. So I can't do that. But I can continue to factor this. So if I set up my numerator, 1 times -10 is -10. 9 is down below. 2 numbers that multiply to -10 and add to 9 are 10 and -1. So it's going to be x plus 10 times x minus 1. And then the second x, a is 1, b is -9, c is -10. So a times c at the top, b down below. 2 numbers that multiply to -10 and add to -9 are -10 and 1. So I still have that x that I factored out down in the denominator. That's a -10, so it's going to be x minus 10. That's a +1, so it's going to be x plus 1. So in this case, you might think more can cancel out, but in actuality, it's just going to be the x up top and down below. If you look, these things are not the same, right? This is x plus 10, x minus 10. This is x minus 1, x plus 1. They have to be exactly the same. So for 22, my final answer is going to be x plus 10 times x minus 1. In the denominator, x minus 10 times x plus 1. And then I'm looking for my restrictions. It's in the denominator. I already canceled that x out, but I still have to exclude it. So the only thing that's going to make this x equal 0 is if it actually equals 0. What's going to make this factor 0? 10 minus 10. So I can't have a positive 10. And this one's going to be a -1. -1 plus 1 is 0, so x can't be -1. All right. 22, that was 22. 23, find the product in the domain. So this is where we're multiplying the 2 fractions together. So for 23, I'll go ahead and just start, factoring the numerator. So x squared plus 6x plus 8, that's a quadratic. I can factor that. So what I'm doing is, this is what I'm doing in my head. This is what I want you to do on your paper if you need to. But if you couldn't do it in your head, then by all means, feel free to. So x squared plus 6x plus 8. A times c is 8. B is positive 6. 2 numbers that multiply to 8 and add to 6 are 4 and 2. So my 2 factors of that numerator quadratic is going to be x plus 4 times x plus 2. One thing you'll notice is even though I'm multiplying this by a separate fraction, look what's happening here. This is x plus 4 times x plus 2. So I don't need to draw a dot and a separate fraction. This is already multiplication. So what I can do is I can take this x plus 3 and just tag it on, right? X plus 4 times x plus 2 times x plus 3. That's exactly what this was telling me to do. So when you're multiplying two fractions, don't keep them as two separate fractions. Just kind of hodgepodge them together and shove them all together. It's multiplication anyways. So your denominator, again, draw yourself an x, set it up, factor it, choose those two numbers. But you know, I'm comfortable enough to do that in my head. So if you are as well, feel free to do it in your head. But if you're not, draw yourself an x. So x squared plus 4x plus 3, I think my two factors are going to be x plus 1 times x plus 3. And then don't forget this is times x plus 2. So I'm just going to tack on that x plus 2. I'm not going to keep it as two separate fractions. So now start canceling. We got an x plus 3 up above and down below, plus 2 up above and down below. And then this is an x plus 4 and an x plus 1. So I can't cancel anything else out. So that x plus 4 is going to stay up top. The x plus 1 is going to stay down below. And now I just have my restrictions. So I'm looking at my denominator. Before I canceled anything out, I'm looking at everything. So what's going to make x plus 1 equal 0? If you don't know, remember, just write it down. X plus 1 equals 0, and then solve it. Right? X plus 3 equals 0. So write down that factor, solve it, -3. But again, you don't have to. X plus 2, what's going to make this equal 0? That's a -2. It's pretty much always going to be the opposite of that constant. Opposite of positive 1 is -1. Opposite of positive 3 is -3. Opposite of positive 2 is -2. What can you plug into those factors to make them equal to 0? That's what you have to exclude. (24). This is already factored, right? Remember, if I say something like x plus 2 squared, that's the same thing as just saying x plus 2 times x plus 2. There's two of these being multiplied, so I can kind of write it a little bit cleaner as x plus 2 squared. Same thing's happening here. This is x minus y squared. So you can write it like that. I'm going to go ahead and break it up just to kind of explain things a little bit more. But x minus y times x minus y. There's two of those. So I have two of those being multiplied. My other numerator, remember, I can just kind of hodgepodge this whole top thing together. They do have a common factor of 3, so I can GCF out of 3. I'm going to write it all the way out in front. If I divide both of these things by 3, 3x divided by 3 is just x. 3y divided by 3 is just y. And then down below, my denominator, the first fraction, is just x plus y. I'm going to throw it inside of a set of parentheses just to clarify that those two things are together. And then down here, x squared minus y squared. X squared minus y squared. Different situation than up here, right? They're different situations. I cannot take a GCF here. There's nothing common between those two things. So this is just going to stay an x squared minus y squared. All right, keep in mind, I can't, whoops, let me close that out. I can't do something like an x minus y up top and then this down below, right? They're different things. They have to be exactly the same. Watch this. This is x plus y. This is x plus y. I have to cancel out the exact same thing. I can't cancel out two different things. So this denominator, I wanted to focus on this on its own step, on its own, thing. Like I said, these, I can't just cancel out x minus y and x squared minus y squared. They're not exactly the same. But let me kind of try to explain what they're doing here. And I think the best way is to give you an example of something that's very familiar to you. So if I tell you x squared minus 9, okay, how can I factor that? Well, we actually saw an example just a couple minutes ago, right? Where is that at? Where did we do that at? Oh, right here. This was on problem number 20. So very similar, it's just b squared minus 9, b squared x squared. It doesn't matter what variable you use. Remember, there's two ways to do this. I can think about, here we go, b squared minus 9 as b squared plus 0b minus 9, because there's no b term. And then I can plug it into my cross method and then factor it that way. Or I can think about b squared minus 9 like this with an equation. I can set it equal to 0. I can add 9 to both sides, take the square root, and just don't forget you're taking the positive and the negative version of that number. So a couple different ways, and this is actually the same thing that's happening here. Really, it's just kind of looks a lot different. So let me show you. In this case, x squared minus 9, would you agree that that's the same thing as x squared minus 3 squared, right? 3 squared is just 9. X squared minus 9, x squared minus 3 squared, same exact thing. Look what they have here. X squared minus y squared, x squared minus 3 squared. So they're using an algebraic definition of what we're doing here. So I can still factor this, right? I just showed you in that last example, problem number 20, that I can factor x squared minus 9. And if you factor it, it's going to give me x plus 3 times x minus 3. Again, rewind this to number 20 and we work through the math and I show you how that works, right? So x squared minus 9 is the same thing as x squared minus 3 squared. Again, look at the connection between these two things. X squared minus y squared and 3 squared. They're just replacing y with 3. So what do you think this is going to factor out to be? So I can rewrite this problem. I'm gonna actually just gonna rewrite the whole thing. X minus y times x minus y times x plus y. And then I had that x plus y down below. And like I said, x minus 9, x squared minus 9, x squared minus 3 squared, that factors to x plus 3 times x minus 3. So I'm sure you guessed it, x squared minus y squared is going to be x plus y times x minus y. If you don't believe me, do the math, right? Take these two binomials and multiply them together. X times x is x squared. X times negative y is negative xy. Y times x is positive xy, so they cancel each other out. And then y times negative y is negative y squared. So that works. Again, just kind of a tricky way to do the same thing you've been doing, just using algebra. So now let's go back through and cancel this stuff out. X plus y, x plus y, x minus y, x minus y. Let me make sure that I got all this junk, 24. Yep. And then so nothing else can be canceled out. A 3 up top, no 3s down below, no factors of 3. An x minus y up top and an x plus y down below. So I've got 3 times x minus y, and then x plus y in my denominator. Don't forget your domain restriction. And remember, the place we're looking at this is when we factor everything out. So the entire denominator there, right? So I'm going to have two variables here. I'm going to have x and y. So let's think about this because there's a lot of domain restrictions. You can make up a lot of things, right? If x is negative 3, y can't be positive 3. If x is 15, y can't be negative 15. So with this problem, it's more generic. Just like with this definition of x squared minus y squared, you could factor that, but it was more of an algebraic definition. Same thing with these domain restrictions. It's going to be more of an algebraic definition. So x cannot equal, look at your problem. If x is 5, y can't be 5. If x is 10, y can't be 10 because 10 minus 10 is 0. So in this case, x cannot equal y, right? If x is 15, y can't be 15 because that would equal 0. And then what else? In this case, I would say there's a couple of different ways you could write that, but I think I'm going to write it like this. I'm going to say that y can't equal the opposite of x. You could always state that x can't equal the opposite of y. It basically means the exact same thing. So however you want to write it, it doesn't matter. You don't need both of them written down. But for example, if x is 3, y can't be negative 3, right? If y is 17, x can't be negative 17. It can't be the opposite. Otherwise, it'll be 0 again. So that's a bit of a trickier one. That's really making sure you understand what's happening here and what the restrictions for that domain are. So tricky problem. That's a good one, though. Oh, find the product and the domain. 25. 25. Find the product and the domain. So this is similar to 23 and 24. You'll notice that 23 is a fraction times a fraction. Keep in mind, this is still a fraction times a fraction, or at least I can write it like that. So let me go ahead and do that. So 25 x plus 5 over x cubed minus 25x times, there's my, what is actually the numerator, 2x cubed minus 11x squared plus 5x. And remember, you can write any number, any variable, any expression, any polynomial. You can write anything divided by 1. It's the same exact thing, right? But now I have a fraction times a fraction. Usually people are more comfortable seeing it like this because then they have a top times a top, a bottom times a bottom, and it just makes people feel a little bit better. But pretty much the same steps as the previous section. So like I said, you can treat two fractions as one solid fraction, right? You don't have to have two separate fractions. Everything's being multiplied. So that top part, that's still x plus 5. Looks like there's a GCF here. I can take out an x from each of those terms. So I'm going to take that x out in front, and that leaves me with 2x squared minus 11x plus 5. So that's going to take us back to our factoring unit. I'll show you again that what we called slide divide bottoms up. Again, there's other methods to factor this, but we'll look at that here in just a second. Then my denominator, it looks like there's an x in both of those terms, so I can take that out in front. If I had x cubed and I took one away, that'll be x squared minus 25x. If I took that x out, it'll just be minus 25. And then the 1. I don't have to write that over there. All right. So here we go. Slide divide bottoms up. So it's still the same setup. So we haven't seen this in a while, so this might be a little bit rusty, so make sure you're just following along with me. 2x squared minus 11x plus 5. You're still setting this up the exact same way. A times c, b down below. So a is 2, b is negative 11, c is 5. So a times c, 2 times 5 is 10, and then b is negative 11. I need two numbers that multiply to 10, and those same two numbers have to add to negative 11, right? Nothing really different, right? This is all the same steps that we've done before. The difference is that a value is something other than 1. Back when we talked about this in the factoring unit, we were talking about a difference between when this is 1x squared versus 3x squared or 7x squared or 2x squared. You just handle it a little bit differently, and that's about to come into play right now. So you still multiply AC at the top, you still put B at the bottom, you still think of two numbers that multiply to 10, the same two numbers have to add to negative 11. Here's that caveat, here's that extra piece. So at the beginning, when I just multiply by 2, well, I can't just randomly start multiplying things by 2. It doesn't work that way. So I have to go back and undo that. Well, what undoes multiplying by 2? Dividing by 2. So I'm going to divide both of these by 2 and simplify. Negative 10 divided by 2, negative 10 halves, right? That's the same thing. That reduces down to negative 5. Negative 1/2, that can't reduce, so it's going to stay a fraction. So here we go. So just keep in mind that difference that we've seen that we haven't seen yet is I need to divide both of those numbers by a, whatever a is, I've got to divide, and then I've got to reduce. If I can. I can't reduce negative 1/2. It is what it is. But I can simplify negative 10 halves. That's negative 5. So my numerator still has an x, still has an x plus 5, and here we go. That's a negative 5, so it's going to be x minus 5, right? Here's the other part, the other difference. Now they call this thing slide, divide, bottoms up, okay? So the sliding part comes up here. When I slid this 2 over to that 5 and I multiplied them, that's the slide. The divide part is pretty straightforward. After I came with those two numbers, that's when I divide by a. So slide divide. Here's the part where you bring the bottom up, bottoms up. Well, this is a fraction, negative 1/2. I can't write, well, I don't want to write it like that, negative 1/2. I can't write x minus 1/2. It doesn't work that way. It's not the same answer. So what I have to do is bottoms up. I've got to bring this, man, I need to give myself a little bit more room. Let me give myself another piece of paper here. If my number is negative 1/2, I need to bring that bottom up. Okay, the bottom comes up, and then it's going to be 2x minus 1. Okay, if my number was 3/7, right, that bottom would come up, and that bottom would be my coefficient to x, and that would be my number, right? If it was 5/3, okay, so that bottom would come up, and it's the coefficient to x. Because that's a positive 5/3, it's plus 5. Okay. So here's what's happening. I've got negative 1/2, so that bottom's going to come up. So it's going to be 2x minus 1. Why is it minus 1? Well, because the number's a negative 1/2. So the 2 comes up as the coefficient, and then it's 2x minus 1. All right, then my denominator, I still have that x. I can factor x squared minus 25, just like the couple that we've already seen. You can use the cross method. You can set x squared minus 25 equal to 0 and do the math, right? Add 25 to both sides. X squared equals 25. Take the square root. X equals positive and negative 5. So I'd have an x plus 5 and an x minus 5. Either the cross method or this method is perfectly fine. All right, now I've got a bunch of factors, a bunch of things that are being multiplied, so I can start canceling. I've got an x up top and down below, an x plus 5 up top and down below, x minus 5 up top and down below. And I think that's it. So all I'm left with is a 2x minus 1. And then I just have to state that x cannot be anything that's going to make my denominator 0. So like I've said so far, I think this is the last time I'm going to say this, all you have to do is take each factor, each thing that's being multiplied, set it equal to 0, and solve it. This is already solved. It's just 0. Here I'd subtract 5 from both sides, so it's x equals negative 5. Here I'd add 5 to both sides, so it's x equals positive 5. So x cannot be 0, negative 5, or positive 5. Uh, 26 more of the same. So we'll go through this pretty quickly. My numerator, it looks like both of those terms have a GCF of 2x. So 2 divided by 2 is 1. If I have two x's and I took 1 away, I'll have 1 left over. Negative 10 divided by 2 is negative 5. If I have an x and I took 1 away, I won't have any x's left over. So I can take this second fraction, this second polynomial, and remember I can just tag that on at the top. So 3x squared plus 4x plus 1, because that's the same thing as 3x squared plus 4x plus 1 over 1, right? Technically, that's my numerator. And then down below, x minus 5, x squared minus 1, just like I did that last problem. Oh, I don't remember what it was. Oh, I think once I GCF those x's out, I had x squared minus 25. Same idea, x squared minus 1. I could either set it equal to 0 or I could plug it into my cross method. Either way, it's going to be x plus 1 times x minus 1. Still have a quadratic here, so I'm going to have to factor that. So this is going to be another slide divide bottoms up. So x, the top is a times c, the bottom is b. Two numbers that multiply to 3 and add to 4. But just remember, this a value is not 1, it's 3. It's something bigger than 1. So I have to go back and divide by 3. Okay. Simplify, reduce. 3 divided by 3 is 1. 1 divided by 3 is just 1/3. I can't do anything with that. So I think I'm ready to write my final answer before I simplify. So my numerator is 2x, x minus 5. That's a positive 1. So it's going to be x plus 1. That's a positive 1/3. So slide divide bottoms up, 3x plus 1. My denominator, x minus 5, x plus 1, x minus 1. I could start canceling. I got a plus 1, x minus 5, x minus 5. Keep in mind, this is an x. So if I had an x down below that's being multiplied, I can cancel that. This x is not being multiplied, right? This is being added to negative 1. So those two cannot cancel out. So my numerator, 2x, 3x plus 1 over x minus 1. And then what can x not equal? Well, basically anything in this denominator, anything that's going to make those go to 0. So in this case, that's going to be a 5. 5 minus 5 is 0. Negative 1. Negative 1 plus 1 is 0. That's a 1. 1 minus 1 is 0. Find the quotient and the domain. This is basically the same exact thing we've been doing with the exception of our first step. So I think I'm going to show this first step a little bit slowly, but then really speed it up because again, we're just doing more of the same. Nothing's really changing. So my first fraction, the numerator, y squared minus 16. If I factor that, I'll get y plus 4 times y minus 4. Again, I'm just factoring that. Remember, I'm just doing that in my head because I'm comfortable with that. If you're not, then just draw yourself an x or do y squared minus 16 equals 0 and solve it, right? You'll get the same answers, positive 4 and negative 4. My denominator, if I factor that apart, I'll have y minus 5 times y minus 5. Or you could write y minus 5 squared. Same thing. I just like to kind of separate them. That way I can cancel individual factors out. Here's the difference though. So let me emphasize what's happening here. If you look at the problem, something like 23, this is a fraction times a fraction. This is a fraction divided by a fraction. So the slogan or the saying that they have here when you're dividing fractions is they say keep keep that first fraction exactly the way it was, nothing changes. Change division to multiplication, and then rearrange. Keep, change, rearrange. I think a couple years ago, somebody in my class had a different one too, but it basically said the same thing. Keep that the way it is, change division to multiplication, and then rearrange that fraction. And essentially what that means is that the top becomes the bottom becomes the top. So if that's the case, my top is going to become the bottom. The numerator is going to become the denominator. So I can GCF out of 3 there. So that's y minus 4. So the old top is the new bottom, and the old bottom is the new top. So if I factor that denominator, it's going to be y minus 5 times y plus 2. Keep in mind, when you're multiplying two fractions, just kind of extend that fraction bar out, right? It's the same thing. You're still multiplying everything. You don't have to think about it as two separate fractions. The importance there is I can do this, right? These are part of separate fractions, but since it's all multiplication, I can take something out of the second fraction numerator and the same thing out of the second fraction's denominator, okay? What else do I got? Minus 5, y minus 4. Looks like I can cancel those out. Nothing else looks to be common. So I think my simplified answer is y plus 4 times y plus 2 over 3 times y minus 5. Okay. This is technically a GCF, so I just like to write it out in front. If you really wanted to put times 3 over here, you could leave it in the back, but this is how you'll see it written. Okay. All right. This one has also got kind of a little caveat to it. We started off with keep, change, rearrange, but the fact of when you're excluding domain, those domain restrictions, you have to exclude anything that ever makes your denominator 0. Right? Even back here at the start. Because technically this was in the denominator at the beginning. Now it's in the numerator once I changed it, but it was in the denominator at the beginning. So you need to look at any step, anytime you had two fractions, anytime you had a fraction with a denominator, you have to exclude that. So let's go ahead and start off with the first fraction, right? We factored that denominator. It gave me y minus 5 times y minus 5. So the only thing I could plug in there to make those two things 0 would be a positive 5. 5 minus 5 is 0. Now I'll move over to the second fraction's denominator. Before I flipped it, right? The original denominator. When I factored that, that became the new numerator. So what's going to make these equal 0? That's a positive 5, which I've already got. That's a negative 2. And then now, once I flipped it, now you're going to look at that new denominator. At any point, anything that was ever in the denominator, you have to exclude that. So in this case, it's going to be a positive 4. All right. 28. This is very similar to, problem was it 24, right? X minus y squared, kind of the same situation happened and a little bit tricky, but it's the same thing as something like x minus 3 squared, right? Oh, hold on. Yeah, same thing. I've just got 2 of those. So I'll separate them. You don't have to, but I like to separate them because that way if I have to cancel out an individual factor, I can do that. So again, if you're comfortable with leaving that as x minus y squared, you're more than welcome to. I like to just break it up because then I can just cancel one of them out. And then, you know, just to explain things. My denominator, x plus y. This is division, so it's keep, change, and then rearrange. So my old top, my old numerator is going to become the new denominator. I can GCF out of 3 from both of those terms. If I divide both of them by 3, I'm left with x plus y. And then my old denominator becomes my new numerator, x squared minus y squared. This is the same thing as we were talking about earlier, x squared minus 9. That's the same thing as x squared minus 3 squared, right? X squared minus 3 squared is the same exact thing as x squared minus 9. And this is the same thing as x squared minus y squared. It's just an algebraic definition. So this is going to be x plus y times x minus y. All right, so this is one single fraction. Start canceling things out. I got an x plus y up top and down below. I did flip everything, right? Let me double check and make sure. Yep, so I did. It's not looking like anything else is common, right? I was hoping more things would cancel out. It's really fun to start canceling a bunch of stuff out and end up with like one or just one thing. But I've just got some x minus y's up top. I've got an x plus y down below, nothing that's common. I got a 3 out in front too, but I don't have a 3 up top. So that's it. So up top, I've got, and I'm going to write it like this just for the sake of simplification, x minus y cubed, because I've got 3 of those. And then down below, I've got a 3 times x plus y. Remember, this is a problem where it's more algebra than other ones. So I'm going to have, because I have 2 variables, I'm going to have 2 domain restrictions. X can't be something, Y can't be something. And let me continue to stress, anytime we're on 28, anytime you're dividing fractions, you have to exclude those domain restrictions at any point when you had a denominator. So at the beginning, where I have 2 denominators, I have to exclude those numbers. Once I flip it and I have a new denominator underneath my second fraction, I have to exclude that number at any point. Exclude them all. So we started off with this denominator, x plus y. So this is very similar to the last one we saw a while ago. If x is 3, y can't be negative 3. If x is 17, y can't be negative 17. Otherwise, they're just going to cancel each other out. So x can't be the opposite of y, or you could have written y can't be the opposite of x. It's the same thing. This was my old denominator. So I already took care of this one, x plus y. What about x minus y? So if x is 5, y can't be 5 because 5 minus 5 is 0. If x is 10/3, y can't be 10/3. If x is 17, y can't be 17. So they can't be the same number. Otherwise, it would be 0. So y can't be x. And then my new denominator, once I rearrange, my new denominator is x plus y. I already took care of that back at the beginning. So I think those are my only 2 domain restrictions. 29, 25x squared minus 4. So I'll just go ahead and kind of show 29 right there, and I'll write it on my paper here in a second. So 25x squared minus 4. X squared minus 9 as my denominator. 5x minus 2 over x plus 3. 5x minus 2 over x plus 3. Okay, so there's 29. My numerator, that's a quadratic, so I'm going to set myself up with a cross. I'm not comfortable doing that in my head, so I'm going to actually show my work. A is 25. B is 0. There's no x term here. And C is negative 4. So 25 times negative 4 is negative 100. B is 0. 2 numbers that multiply to negative 100 but add a 0 are positive and negative 10. Just don't forget that you have to go back and divide by A. A in this case is 25. And then reduce. Always reduce if possible. 10/25 can reduce down to 2/5. And then obviously negative 10/25 can reduce down to negative 2/5. So for my first numerator, That's a positive 2/5. Remember, keep change, rearrange. Slide, divide, bottoms up. That bottom comes up. So it's going to be 5x plus 2 times 5x minus 2. The bottom came up. My denominator, I think I could just go ahead and throw that one on there. X squared minus 9, if you factor it, it's going to be x plus 3 times x minus 3. Keep, change, rearrange. So this denominator becomes my numerator. The numerator becomes my denominator. So x plus 3 goes up top. 5x minus 2 goes down below. Luckily, nothing to factor here. There's no GCFs. It's just ready to flip and start canceling. So x plus 3 out of the top and bottom, 5x minus 2 out of the top and bottom. And I think the only thing that's left is a 5x minus 2 up top and an x minus 3 down below. And then my domain restrictions, just don't forget, we want to talk about the original denominators. And then once I keep, change, rearrange, right, I want to exclude those denominators as well. So this original denominator is right here. I didn't do anything to it. So it's going to be x can't be -3 or +3, because that'll make both of those go to 0. Originally, this was an x plus 3, so x couldn't be -3. I've already got that. And then my new denominator, 5x minus 2, what's going to make that equal 0? We'll literally just write equals 0. 5x minus 2 equals 0. And do the math. Divide by 5. So x equals 2/5. So in this case, if x equals 2/5, my denominator will be 0, and that's a big no-no. So there's 29. 30, almost done. I'm guessing this is going to be a doozy. Maybe not too bad. So for number 30, let's see if I can get my book up here. For number 30, it looks like my first numerator, I've got an x squared that I can take out of each of those, right? I've got 4 here, 3 here, 2 there. So I can take 2 out of all of my terms. So if I had 4 x's and I took 2 of them away, I'll have 2 left over. If I had 3 x's and I took 2 of them away, I'll have 1 left over. If I had 2 x's and I took both of them away, I'll just have the -30 left over. And that denominator, x squared minus 3x minus 18, if you factor that, you're going to get, what, -6 and 3. So x minus 6 times x plus 3. So all I did was plug that into my cross, right? That's all I did. Divided by, so I'm going to go ahead and kick this up top. So the old denominator is going to become my new numerator. So x squared minus 36, if I factor that, that's going to be x plus 6 times x minus 6. And then my old numerator, which is my new denominator, keep, change, rearrange, right? Just flip that fraction. I can GCF out an x, and that'll leave me with x squared plus x minus 30. All right. Scoot my book back down. It's easier to write like this. Okay. The first thing I want to point out, and you can do this, if you don't catch it, that's fine. You could factor that quadratic. You could factor that quadratic. And I didn't, just because they had GCFs and I wanted to take them out first. But you could, and then simplify. But take a look. This set of parentheses, this is x squared times x squared plus x minus 30. This is x times x squared plus x minus 30. Those two sets of parentheses are exactly the same. Okay, so you could just cancel those out right at the beginning. The only reason I'm not going to, I'm going to go ahead and factor it, is because in the end, when you need to put those domain restrictions on, you're going to have to factor that out anyways to figure out what those values are. But just to emphasize that, you could factor those out right now. They're the exact same thing. You could cross them out. If you had a problem that didn't ask for domain restrictions, bam, bam, you wouldn't even have to factor it. But since I do have to state my domain restrictions, I'm going to factor it. So I still have an x squared up top. Again, I'm going to factor this, which just means plug it into my x, do the math, come up with those two numbers. That's going to be x plus 6 times x minus 5. Then my denominator. My numerator. And I'll just kind of keep this as one big fraction. So x plus 6 times x minus 6. And then we already factored that, right? So I'm going to put the same thing. I've got the x still there. Almost forgot it. And then I have x plus 6 times x minus 5. See, once I factor that, now it's a lot easier to come up with those domain restrictions. Because here I've got 1, 2, 3, 4, 5. 5 things I have to exclude. So, but we'll talk about that here in a minute. So I've got 2 x's up top, 1 x down below. So if I take one of the x's from up top, I can take 1 from down below. So I still have 1 left over up top. I got an x plus 6 up top and down below, x minus 5 up top and down below, x minus 6 up. See, these are the ones that I really enjoy because you get to cancel out a bunch of stuff. And you started off with all this garbage and now you end up with just a couple of things. So I still have an x. I still have an x plus 6 up top. Down below, I still have an x plus 3. And then my domain restrictions. What's going to make x minus 6 equal 0? Positive 6. Remember, you're just taking the opposite of that number. That's a positive 3, so it's going to be negative 3. That's just x, so that's going to be 0. Opposite of positive 6 is negative 6. Opposite of negative 5 is positive 5. Let's take a look at this last problem and just kind of see how involved it is. A rectangular prism with a volume of blank cubic units has a base area of blank square units. Find the height of the rectangular prism. So this type of problem is very similar to, what was it? Example 6. So this is back here on page 213. We kind of talked about it, but we actually didn't work through it because, again, this is, this is a difficult concept, and I think this was just a little much to talk about in part 2. But this isn't too bad. This is kind of more of the same thing. It's just kind of a real world problem. Keep in mind that volume, right, there's a formula for both. The formula is base times height. So volume equals base times height. So if you take, this is talking about a prism, so like a cube, something like a shipping box or something like that. If you find the area of the base and just multiply it by the height, that'll give you the volume, how much stuff you can put on the inside of the box. So don't let them, kind of make this a little bit confusing with all the algebra that's happening here. I'm going to go ahead and set it up, and I think it's pretty straightforward, so we'll go ahead and solve it. So volume equals base times height. A rectangular prism with a volume of that. So I'm going to go ahead and replace V with 3x cubed plus 7x squared plus 2x. 3x cubed plus 7x squared plus 2x. Okay. A base area of x squared plus 2x. So I'm going to replace b with that x squared plus 2x. So 3x cubed plus 7x squared plus 2x equals, base is going to be x squared plus 2x times height. Okay. Find the height. So basically they're giving you 2 out of the 3 missing pieces of, or 2 out of the 3 pieces of information. You have to find the height. In this case, what you're essentially going to do to solve for this, to solve for h, since this is h times the base, how to get that by itself is you just want to divide by that base, x squared plus 2x. So if I do that, I've got to divide both sides by x squared plus 2x, because look what happens on the right, x squared plus 2x on top, x squared plus 2x on the bottom. What I'm left with is just h. So I solved for h. I still have a kind of a bunch of mess over here that I'm gonna have to simplify, but we'll get to that. So I've got 3x cubed plus 7x squared plus 2x. All three of those have a common factor of x that I can GCF out. So it's 3x squared plus 7x plus 2. Same thing with my denominator. They both have an x, so I can factor out an x. It leaves me with x plus 2. These are nice when I just have my AB term, because once just by taking the GCF, it's factored. There's no more x squared here. I simplified that. But I do have a quadratic here, so I'll go ahead and draw my x. A times c goes at the top, b goes down below. Two numbers that multiply to 6 and add to 7 are 6 and 1. Don't forget, you got to go back and divide by a and simplify. So here we go. I still have an x up top. This quadratic factored apart, that's a positive 2, so it's x plus 2. That's a positive 1/3, so that bottom comes up as 3x plus 1. And then my denominator, x times x plus 2. And now once I simplify this, I'll have my answer, what my height should be. I've got an x up top and x down below, an x plus 2 up top and x plus 2 down below. So the only thing I have left is 3x plus 1. Just remember, you can never divide by 0. So at any point, if you ever had a denominator, which we do, you have to exclude those values of x. So x cannot equal, in this case, x cannot equal 0. And then over here, x cannot equal -2. If you got any questions about this, make sure you reach out to me. This is a little bit of a difficult skill concept to kind of master. We've talked about this before. When you have these concepts that take multiple steps, right? This is just one problem right there, and there's a lot of ink on the paper. So when you have these problems that take multiple steps, sometimes students tend to kind of, disconnect and throw their hands up and just be like, I don't get it. It doesn't make sense. But just make sure you're pushing through this, you're persevering, you're reaching out to me for help, you're staying after class and asking questions. Make sure you're doing whatever you have to do to be successful.